Hello and welcome to 4-1. We're going to begin with radians and angles. Now today you are going to learn something, a concept that you've never learned before. Up till now in this class we have dealt with things that you have learned either in Algebra 2 or Geometry or Algebra 1. But today you are going to learn something that you've never yet learned. It's going to be a beautiful thing. We're going to talk first about the definition of an angle. Now, this you do know. Some terms that we're going to talk about, though, we're going to talk about the terminal and the initial side. So, the initial side is where the angle starts at. The terminal side is where it ends at. For the purpose of our lessons, the initial side is typically going to be, if you look in here at this, diagram, the initial side is going to be right here along the positive x-axis. A lot of the angles that we will sketch and that we will deal with will correspond to the x and y axis. An angle is basically two rays with a common endpoint. That's what an angle basically is. You've got two rays, they extend off in infinite directions, and they have a common endpoint that is called their vertex. So here you have the vertex of the angle, the initial and the terminal side. In figure 4-2, the vertex of the angle is found at the origin of the coordinate plane, and you have an initial and a terminal side. The measure of angle is determined by the amount of rotation from the initial side to the terminal side. Up till now, you have learned to measure angles in degrees. Today, you are going to use a new concept called a radian to measure the angle in trigonometry. 1 radian is a measure of an angle, a central angle theta, that intercepts an arc equal to the length of the radius of a circle. So algebraically, you would say that the angle theta, measured in radians, is the arc length divided by the radius, basically. Take a look at this. What this figure is basically showing is that this length of 1 radian right here is equal to the same length of this. Think of it, if I were to get you a pizza from CC's Pizza, and no, I'm not actually going to do that, but let's say hypothetically I were. A slice of a pizza with a crust that's 1 radian long would have the same curved length on the crust as it would the sliced length to the center of the pizza. As a result, you have about 5 and some radians that can make up any circle. Now, let's say for a moment that I have the circumference of a circle, and it's 2 times the pi times the radius. Okay? We all know that the circumference of a circle is 2 pi r. So that means if I have a radius of 1 in this circle, then the circumference would be 2 pi. So thus we can say that from start to finish, there are 2 pi radians in a circle. We can also then state that 2 pi is equal to 360 degrees, which then would mean for every 1 pi, I have 180 degrees. Which means that 1 radian is equal to 180 degrees over pi. And we're going to show you this definition here in a moment. I just want you to see how we derive that. So, sketching and finding coterminal angles. So, Another new concept that you've never dealt with before is called angles and coterminal angles. Up till now, you have never had an angle that is more than 360 degrees because there are 360 degrees in a circle. So how could you possibly have an angle that's larger than 360 degrees? Well, let me show you. So for the first one, 13 pi over 6. If I were to put this in terms of degrees, I would have, let's see here, that would be, take away the pi's, that becomes 30. So I would have 390 degrees is basically what this is. So what a coterminal angle says is, all right, I've given you some angle greater than 360 degrees. Now subtract away from it as many 360 degree increments as you need so you get an angle that is less than 360 degrees. So in this case, 390 degrees, when I subtract 360, I get 30. In the same way, if I do it in radians, I have 3 pi over 6 minus 2 pi equals pi over 6. I would want to put this in a common fraction with that one. So 13 pi over 6 minus 12 pi over 6. And that's what gives me my pi over 6. So the coterminal angle for 13 pi over 6 is pi over 6. For 3 pi over 4, now this is an angle less than 360, but I still want to find the coterminal angle. I still subtract 360 degrees. So 3 pi over 4 times 180 over pi, to get it from radians to degrees, is 135 degrees. So minus 360 gives me 5 pi over 4, which gives me negative 275. In radians, that's negative 5 pi over 4. So I would take 3 pi over 4 and subtract it by 2 pi, which is 8 pi over 4. And that gives me negative 5 pi over 4. For C, if I have negative 2/3 pi, well, negative 2 pi over 3 times 180 over pi gives me negative 120 degrees, minus 360, and I get 240. So if I have negative 2 pi over 3, and I subtract 2 pi, which means I'm just going to add 6 pi over 3, I will get 4 pi over 3 as my answer. Don't worry if you're feeling a little bit confused right now. You will get the hang of it, I promise. So if it is possibly to find the complement and the supplement of an angle. Remember, complementary means they add up to be 90. Supplementary means they add up to be 180. So I'm going to say for A, 2 pi over 5, and then I'm going to subtract, that rather, from pi over 2 because that is 90 degrees. That will become 5 pi over 10 minus 4 pi over 10. So I'll get pi over 10 as my answer for the complementary angle. For the supplementary angle, I'll simply take pi and minus it by 2 pi over 5, because pi is 180 degrees. So I'll have 5 pi over 5 minus 2 pi over 5, which is 3 pi over 5. For b, I will take pi over 2 and subtract 4 pi over 5. For that, I will get 5 pi over 10 minus 8 pi over 10, which gives me negative 3 pi over 10. In this case, we would say that it does not have a complementary angle, because a complementary angle would be, two complementary angles would be angles that are less than 90 that add up to equal 90. Well, that won't work. Let's try pi minus 4 pi over 5. 5 pi over 5 minus 4 pi over 5 gives me 5 over pi, radians. Remember, these are in radians. Now, anytime you want to convert from degrees to radians, you can multiply the degrees by pi radian over 180 pi. Over 180 degrees, excuse me. Now, we never write the term rad with it. We never do that. But they're just showing you that that's the unit of measurement. So to convert from degrees to radians, I simply multiply it by pi over 180. To convert from radians to degrees, I multiply it by 180 over pi. You can see here some basic relationships. So 30 degrees is pi over 6. 45 degrees is pi over 4. Pi over 3 would be 60 degrees. Pi over 290, pi is 180, and 360 degrees is 2 pi. We are basically learning to measure and state angles in a new language is what we're doing. When we do not specify a unit of measurement, we assume that it means radians. So if I say that theta equals 2, then we're saying that the measure of angle theta is 2 radians. So converting from degrees to radians, I multiply by pi over 180. So I get 135 pi over 180. And now I simplify my fraction. Take out a 5 out of the top and bottom. And I get 5 goes into 13 two times. And I'm left with 27 pi. And 5 goes into 18 three times. I've got a remainder of 3. And so I get 27 pi over 36. Keep reducing. I can reduce top and bottom by 9. So I'll get 3 pi over 4. For 540 degrees, 540 times pi over 180. So I get, if I drop my zeros, I get 54 pi over 18. Let's reduce top and bottom by 9. 9 goes into 54 6 times, and 9 goes into 18 2 times, so I get 3 pi as my answer. For negative 270 degrees, so I do negative 270 times pi over 180, and that will reduce to negative 27 pi over 18. I can reduce by 9 to get negative 3 pi over 2. we will be doing a lot of practice in class on converting degrees to radians and radians to degrees. So negative pi over 2, multiply it by 180 over pi. Pi should always cancel. When I go from radians to degrees, there should always be a cancellation if a pi is present. Okay? And that will give me negative 180 over 2, negative 90. 9 pi over 2 times 180 over pi. Pi's cancel. 2 goes into 180 90 times. 90 times 9 is 810. And let's make sure to put our degree symbol. Finally, 2 radian times 180 over pi will give me 360 over pi.